Things are heating up. Starship is finally about to start. It has achieved all of its test goals and little stands in the way of an orbital flight attempt. The flight of by far the largest and most powerful rocket ever built could be imminent. So I think it's about time to take a look at the flight path planned by SpaceX. And I want to clarify the question, who might be able to see the Starship flight from Earth? In the video today we go over the test flight parameters SpaceX filled with the FCC and consider what they mean for the flight path, flight time and for the Starship. So you'll be primed for the first flight, which could be historic and will almost certainly be broadcasted live by SpaceX. I'm Mo, I'm a naval architect from Hamburg, Germany, and my channel Senkrechtstarter is the largest space channel in the German-speaking world. Since many of my video topics are not available in English, I started a secondary channel Senkrechtstarter Global. In case you're wondering what Senkrechtstarter means, it's the German word for vertical takeoff. Since the data is very modest and SpaceX is also known for doing things quite differently in the end, the data and trajectory I'm about to present to you, please take with a grain of salt. But based on what we know to date, it is the best we've got. We have been able to view several documents that SpaceX has filled with the FCC. The FCC, that's the Federal Communications Commission, which regulates the allocation of radio frequencies in the US. Not to be confused with the FAA, the Federal Aviation Administration. This is the Federal Aviation Authority in the US, which ultimately also issues launch permits for rockets. As of today, when I'm recording this permission has not yet been granted for the Starship. From the documents filled by SpaceX with the FCC, details were provided for the launch phase and a possible landing of the Starship. From Boca Chica in Texas, where the Starship is currently being assembled and tested, it will first travel 1,500 kilometers over the Gulf of Mexico in the easterly direction. As with every rocket launch, the first 10 minutes in particular are very exciting. The launch itself, of course, will the Super Heavy booster really take off? Or will it completely destroy the launch facilities in the event of a catastrophic failure? Elon Musk has said himself, however it will end, entertainment is guaranteed. If the launch of the Starship with the Super Heavy booster as the first stage is successful, after 169 seconds the 33 Raptor engines will stop firing. If some of the many engines fail, probably the firing will go on some more. 2 seconds after main engine cutoff, MECO, the stage separation takes place and the actual Starship, the upper stage, will start firing 5 seconds after the stage separation. Stage separation and second stage ignition are one of the most critical stages in a rocket launch. Enormous numbers of even established rockets have been lost here. Even SpaceX had some problems with the Falcon 1 to pass this point successfully. I talked in detail about this with one of the first SpaceX employees ever, Hans Königsmann. The interview is in German but with English subtitles. Back to Starship. If everything goes according to plan, after the stage separation the Starship will accelerate further towards the planned apogee. Between the southernmost point of Florida, Key West and Havana, the Starship then flies over the 150 kilometers wide Strait of Florida. Then the flight path continues over water between Cuba and the Bahamas. Only over the Turks and Caicos Islands, which belong to Great Britain, the Starship then apparently flies over land for the first time. There are no more official pictures for the rest of the flight. Only the landing 100 kilometers north of Hawaii in the Pacific is shown with a screenshot. We know from the current FCC document that apogee, or the farthest point from Earth in the trajectory, will be about 250 kilometers above normal zero. Although we still have the information that a scheduled landing is to take place 100 kilometers north of Hawaii, no further orbital parameters are known. But we do have a table with timecodes for an orbital flight. With these timecodes you can plan well if you want to watch the first launch of the Starship live. We will take a close look at these in a moment. But back to the flight path. As just described, the flight towards the Caribbean is already chosen quite concretely and seems to purposefully avoid land masses. So the angle with which the Starship will fly parallel past Cuba is already approximately the angle of the final orbit. A small side note here, with a so-called dagleg maneuver, it is still possible to exert a great deal of influence on the inclination. But this is not efficient. Roughly speaking, from Boca Chica past Cuba, it is plausible that the Starship could come out on the other side of the Earth near Hawaii. The most plausible quick and dirty simulation was made with a small globe. Of course, the method is not very accurate and you must not forget that the Earth is rotating. That means if you think on an orbit that you come out exactly at Hawaii, the Earth has rotated a good bit further until you reach that point. This can also be seen on plots of the ISS trajectory, where the current position is plotted as well as the point on Earth over which the ISS will pass during the next orbit. Basically, you already have an idea of the trajectory. To visualize the whole thing a little bit better, I asked Robert from the German YouTube channel Wintermancer to visualize the flight path in Kerbal Space Program. The video of Robert is not flown with a Starship, and so we have to take the accelerations a little bit with a grain of salt, but basically the orbital mechanics and Earth rotation fits very well for our purpose. If you start at Boca Chica with a compass heading of 97 degrees like Robert did, and then put yourself on an orbit with an inclination of 26 degrees, that takes us right between Cuba and Florida. So exactly as the FCC documents. And we also come out perfectly near Hawaii in the first orbit, and we are so low there that Starship definitely comes back to Earth through the braking effects of the Earth's atmosphere. That's why, of course, you can argue that this won't be an orbital flight at all if the perigee is inside the atmosphere. But honestly, there are only 50 to 100 meters per second delta V between a stable orbit and the safety orbit with guaranteed re-entry. That's really not so much. To explain the word heading, this means the compass direction. A 0-degree heading goes to the north, a 90 degrees heading is a trajectory in the easterly direction seen from the starting point. So a 97 degrees heading means a takeoff in an easterly direction with a slightly southerly component of 7 degrees. With this flight direction, we head for an orbit with an inclination to the equator of 26 degrees. Compass heading and orbital inclination are not the same. Now, of course, you may ask, why the 97 degrees? Yeah, because if you look at Boca Chica, it is already on the 26th degree of latitude, so it should be enough to fly exactly with a 90 degrees compass direction to the east to reach an orbit of 26 degrees, right? Yeah, but the Earth is also rotating, and we have to compensate or include this rotation in the orbit control. But this actually makes things a little bit easier for the rocket, because you get the rotation as a gift. Where do you get the most energy? Yeah, exactly at the equator. But this is only really relevant for geostationary orbits. For polar orbits, which are especially interesting for Earth observation, you can also launch very well at higher latitudes. And while our Kerbal Space Program rocket accelerates towards the apogee, the furthest point from Earth, we see how the trajectory goes perfectly along the path described in the photos in the FCC files. After the stage separation and ignition of the 6 Starship Raptors, the booster will turn and will perform a boost back burn. We will clarify how to proceed with the booster in a moment. Now, first of all, to the further flight of the Starship. Now, of course, the exciting question is where the orbit will continue. The FCC document does not provide any photos or data for this. Yeah, from the Caribbean it then goes over the Atlantic Ocean eastwards past Brazil. At the border of Angola and Namibia, the Starship flies over the mainland for the first time since the Caribbean to reach then between Africa and Madagascar, probably the most distant point, the apoapsis. From now on, the orbit leads the Starship closer and closer to the Earth. The Starship will then reach its next landmark near Australia. Here it flies between Australia and Indonesia, and then pass over the Isle of New Guinea. Of course, only the imaginary track on the ground, the Starship is still in space at that time. We assume that an orbit is approached which leads in any case to the fact that Starship comes back to Earth. That means an elliptical orbit whose lowest point, the periapsis, is so far in the atmosphere that the air resistant during re-entry definitely leads to Starship coming down. Whether in one piece or in parts, that remains to be seen. And if Starship should break apart during re-entry, those parts should not hit North America. That means if SpaceX should lose control over the Starship at the most unfavorable point, pieces of debris must fall in the Pacific Ocean well before North America. But that's just speculation, since we don't have any other orbital parameters. You can now argue whether it would be an orbital flight at all. Fun fact, Yuri Gagarin never flew a full orbit around the Earth. But I think whoever reaches orbital velocity can rightly speak of an orbital flight. What do you think? Feel free to write me below the video. Assuming the flight went as planned until re-entry into the atmosphere, that would already be an immense success for SpaceX. Quite a few critics of the Starship program would then go very, very quiet. But even if the flight ends much sooner in a fireball, SpaceX will have plenty of data to do better next time. And the next boost and the next Starship are as good as ready. Elon Musk had announced on Twitter that he wants to produce 5 full Starship stacks of booster and Starship this year. How many will fly remains to be seen. For the Starship concept to work with complete reuse, even more has to happen than launching the largest and most powerful rocket into orbit. For a splashdown of the Starship, not only must the flight go smoothly, but more importantly, so must the re-entry. While SpaceX and others have good experience with ablative heat shield technology, ceramic heat shield is the pinnacle of re-entry. That SpaceX is the best rocket builder in the world is probably beyond question by now. That didn't fall from the sky. SpaceX has worked very hard to achieve that over the past years, certainly with the help of NASA. It remains to be seen how quickly this mastery will be achieved with the Starship heat shield. I did an interview with Professor Chris Combs about heat shield and hypersonics. Professor Combs sees many unanswered questions about the Starship's heat shield concept. A link to the video is in the description. If the re-entry is successful and the heat shield has slowed down the Starship from orbital velocity to only hypersonic velocity, now comes the part we already know from the altitude flight tests. Now that the horizontal velocity has been completely reduced, the Starship falls toward Earth without making any appreciable stretch. Since this free fall takes place with the belly in front, the so-called belly flop, that is with a lot of surface against the direction of fall, the speed will reach terminal velocity of about 300 km per hour quite early. In order to achieve a landing, the Starship has to flip again. Doing this flip maneuver and the ignition of the sea level Raptors against the direction of the fall, the braking acceleration will increase again briefly and then, in the best case, enable a soft landing. And SpaceX also gives us a timecode for the landing in the FCC files, 5,420 seconds after launch. So 90 minutes after liftoff in Boca Chica, the landing would take place. Whether the stream goes that long or if the booster even leaves the launch table in one piece will be seen. Should it take off, you should at least watch the first 10 minutes. That would be the time frame in which a Super Heavy booster landing would take place. My video about the soft water landing of the Starship Super Heavy booster and its swimming behavior is one of the most viewed videos on Senkrechtstarter. I also link you the video below in the description. Realize this, no one else on Earth has this landing capabilities except SpaceX. No country, no company as of spring 2023 has demonstrated orbital booster landing. And we're not even talking about SpaceX precision or success rate. For more than 100 landing attempts, SpaceX has not lost a booster on landing. And if that wasn't challenging enough, making the largest rocket ever just as reliable, SpaceX is planning a lot more here. Rapid reusability is the goal, similar to a commercial airliner. We'll find out how that's going to work, what Mechazilla is and what tricks SpaceX has up its sleeve in the next video. If you watched the video this far, I obviously didn't lose you on the landing. If you liked it, feel free to leave a like, and if you're new here and don't want to miss more videos about spaceflight, rocket technology and the latest development in spaceflight, be sure to subscribe to Senkrechtstarter. Big thanks go to Robert and Aeneas for helping me with this episode. Can't wait for the next big leaps out there. Whether it's with Starship, SLS or New Glenn, our personal Apollo moment. If you feel the same, don't forget to like. See you next time. Always stay vertical. Yamo.